Okay, standard deviation is spread. So if you have, let's just say 5 numbers, 1, 2, 3, 4, 5, we want to know how spread out they are versus, well, let's just start from here. It's not spread total like 1 to 5, it's spread from the average. So first we have to, so it's spread around the average, or spread from the average. So first we have to come up with the average of all of these. So the average here is 9, 10, 11, 12, 13, 14, 15. So it's 15 out of 5. So here the average is 3. I made it that way so that it was nice and easy. So the average is exactly 3. So what we do is you take 1, 2, you take the data, and you subtract each one of them from the average. So it's the 1 minus 3, so that gives negative 2. It's saying that the 1 is 2 below the average. And then the 2 is 1 below the average. And the 3 is 0 below the average. And the 4 is 1 above the average. And the 5 is 2 above the average. Okay. That's actually called the variance, how much these are varying. Okay, so the 1 is varying from the average by negative 2. Okay, if we add all that up, this is the symbol for sum. Negative 2, negative 1, 0, 1, 2, it always adds up to 0. So anytime you do, that's like the definition of average. If you always do this and you add them up, you always get 0. So to get around that, we square each one of these numbers. So I'm going to take negative 2 squared, which is positive 4. And then negative 1 squared is positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. See, now we have a sum. So to get around this problem, we square them all. And now we have 4, 5. We have 10. Okay. We want the average spread. So the spread around the 3, when we square it, is 10, but we want that average. So I want the average of the squared spread. Okay, well, there's 1, 2, 3, 4, 5 of them, so I'm going to divide that by 5. So this is called the variance. The variance is 2. But now the variance has been squared. See, we used all the squared numbers. Really, it only varied by 2, but we counted it as 4. Here it only varied by 1, but we squared it. We took this one, so this is really the squared answer. So the standard deviation gets back down to the normal scale. So we take the square root of the variance is the standard. So see, here we square it up, then we square it down. The reason we square it up so that it doesn't always add up to 0. So we square it to get an answer, then we square root it to get back to the standard deviation. So the standard deviation here is the square root of 2, which is 141. So that's considered the standard deviation of this data set around the 3. Okay, I divided it by how many there were. If you divide it by how many there are, that assumes that this was all of the numbers, that those 5 numbers were the entire population. Okay, well, most of the time this is a data set taken a smaller one, that this was just be a sample. So if the standard deviation is all of the numbers that there are, it's out of the population, you divide it by n. So the standard deviation formula is the variance divided by n, and then you square root it, n being how many there are. That symbol is the Greek symbol. It's this one. So this is the population. But if these were taken from a larger group of numbers, then it's called this kind of S. It's an English S. So it's either a Greek S or it's an English S. This also means the standard deviation, but it's of a sample. So this one is as a population. If the numbers were the entire population, this one is if the numbers are a sample of the population. It's exactly the same thing, except you divide it by n minus 1. So in this particular case, if those numbers were of a sample, it would have been the square root of, let's see, that would have made it 10 over 4, because this would have been n minus 1 instead. 10 divided by 4 is 2.1, so it would have been the square root, 2.5 divided by 4. Oops, no, it's right here. We already divided by 4, so this is the variance, 2.5, and then the square root. So there's a small minor difference, and whatever the square root of 2.5 is, it's a little bit different. It's a little bit more than, I guess I could just type it in here and see. The square root of 2.5 is 1.58. So samples are a little bit wider spread than the entire population. Okay, so really your question is, how do you do that on a calculator? Okay, here's how. There's two ways. Here's the first way. So right here, the stat key. So we hit the stat key. And this gets you into a spreadsheet. So there's a mini spreadsheet inside of there. So you hit enter on edit, and there's a whole bunch of spreadsheets. You have 6 of them as a default. List 1, list 2, list 3, list 4, list 5, and list 6. So as you can see, I have a bunch of junk in all of mine. If by chance you don't have one of those, let's just say it showed up and you didn't have list 1 like that. So when you scroll around, you don't see a list 1. Okay, that just means it's been deleted. So for example, if I sit on list 4 right there, see I'm up on, if I sit on one of the data points and hit delete, it erases that data point. If I sit on the title list 4 and hit delete, see how it erases the whole thing? It goes from now list 3 to list 5. But it only deletes it from the screen. It doesn't really delete it out of the data. So I'm going to hit the stat key one more time and come down here to setup editor, and that brings everybody back. That puts it back to the default. Now when you hit stat, enter, you will see there's list 1, list 2, list 3, list 4, list 5, and list 6 again. So if you don't have them all, just go to stat setup editor and you have the lists. Okay, if there's numbers in there, go to the very top and say clear. Clear doesn't delete it, it gets rid of all the data in there. So like on list 2, if I push delete, it'll go away. If I push clear, enter, it just makes it empty. Okay, so clear out list number 1 and put the data in there. 1, 2, 3, 4, 5. Okay, so if you put the data in the spreadsheet, and now right there's quit, so I'm going to say second quit. That gets you out of the spreadsheet back to the main screen. Okay, now I'm going to go back to stat. So when we hit stat right off the bat, that gets us in the spreadsheet. If you go over to calculate, this does calculations on the spreadsheets. Okay, so this calculates things on the spreadsheets. The very first one is one variable stats. That finds a ton of stuff. Hit enter on one variable stats, and we put the data in list 1. Right there in yellow is list 1. So I want to say list 1. I have to tell it where we put the numbers, because we could have put the numbers in list 2 or list 3 or list 4. So I want one variable, I want one variable stats on list 1. Push enter. Okay, look what it gives you. It gives you the average, 3. That's what I found out right there by doing it by hand. It gives you what they add up to. Those add up to 15. It gives you, if you squared them all, you don't really need this kind of stuff. If you squared them all, it gives you 55. Okay, see the SX? That's the standard deviation for a sample. That's this one right here. The sample standard deviation. I said it was 158. See, it's 158. That's the square root of 2.5. And there's the standard deviation if it's a population. That's the square root of 2. That was this one. It was 141. So it just gives you the answers. But look what else it gives you. See how it says down arrow? If you go down one, it tells you what the smallest number in the data set is. I mean, ours was so small, so that's not very big. But if you have 100 numbers, it will tell you which one was the smallest. I don't know if you've gotten to this yet, but it also tells you what the first quartile is. It also tells you the median number. So it gave us the average and the median. It also gives you the third quartile, and it also gives you the maximum. So when you get to if you haven't gotten to it yet, you're going to need the quartiles. So the quartiles are 1.5 and 4.5. So it gives you all of those things. That's the easiest way to find standard deviation, is put it in a list and do one variable stats. There is another way, however. I'm going to clear all of that. There's another button right there called lists. See above stat, it says list. Those are things you can do to a list, and we have all this data in a list. So if I say list and go over to math, that's mathy things you can do on a list. If I come down here to standard deviation and say list 1, it'll just give you the standard deviation of list 1, but it does it as a sample. It only gives you the sample standard deviation, not the population standard deviation. So you can either just go to the list button and go to math, or you can just put, it's probably faster just to hit calculate one variable stats. And not only that, you don't even have to put list 1 in there. List 1 is the default. You only have to put things in there if it's not in list 1. If you just hit enter, it automatically does it to list 1. So if you have a whole bunch of numbers, let's say we have 1, 2, 3, 4, 5, and then like 3. Okay, I know. Let's say we have 1, 2, 3, 4, 5, and we want to compare it to 1, 2, 3, 4, 10. That should be a much wider standard deviation because it's this one. First of all, the average is not going to be 3, so we're going to be subtracting things other than 3. And then 10 is going to be pretty far away from it. And then when we square it, the error, it's going to be way far away from it. So let me go back up in here and say 1, 2, 3, 4, 10, so we can just compare. So 1, 2, 3, 4, 10, second quit, stat, calculate, one variable stats, enter. See, now the average is 4 and the standard deviation is 3.16. So see how the standard deviation got much wider because of that 10. When it was 1, 2, 3, 4, 5, it was 158. 1, 2, 3, 4, 10 is now 316. So it's an extremely helpful button. And if you have a whole bunch of data, you just put all the data in and you hit one button and you get all of the answers.